Welcome again to the complete free Flutter course, presented by yours truly, Ovidius Mazuru. In this video, Module 2's third lesson, we're going to continue exploration of object-oriented programming in Dart, and specifically we'll look at polymorphism, and two keywords which will be useful when talking about OOP, specifically abstract and super. So let's start by actually defining polymorphism. It is one of the four pillars of OOP, but what is it really? Let's take a quick look at Wikipedia, see what Wikipedia has to say. So Wikipedia defines it as, it says, in programming languages and type theory, polymorphism is the provision of a single interface to entities of different types, or the use of a single symbol to represent multiple different types. I mean, what does that mean? That is confusing. But polymorphism is actually a pretty simple concept once you really understand it. And there are three different types of polymorphism, but Dart only supports one type, which is the last one, subtyping. If you don't know what these things mean, don't worry too much about it. When you become more experienced, and especially if you decide to study other programming languages, this will become something that will be second nature to you eventually. But for now, all you need to know is that Dart does support polymorphism, and we'll take a look at how we do that. Specifically, because it is, as I said, subtyping, Dart allows us to use a class as its parent type. So again, what does that mean? Polymorphism is something which we really need an example to understand properly. So let's start with a class and we'll say shape. And we'll give shape a method. All shapes can have a void get area. And in fact, instead of a void, I'll make it a double. One more thing about this though, is when you think about a shape, what is a shape really? It can be so many different things, but if I tell you, for example, to imagine a shape, you can't imagine shape. You can imagine square, you can imagine rectangle, you can imagine star, you can imagine some kind of interpretation of shape, but you can't imagine what shape by itself is. This means that shape is abstract. The idea of a shape, it can only be expressed in things which are shapes, but not in a shape itself. Similarly, if I look at this function, get area, how do I get the area of a shape? I mean, it depends what the shape is. I don't know how to do this function for the actual shape. And because of this, we can add the keyword abstract before my class shape. And I'm getting an error for some reason. And of course, eagle-eyed viewers might have noticed that I tried to declare my class as a function, which is not correct. Classes do not take those open and close brackets, which would allow us to take some kind of arguments. We can't do that. We would define that in the constructor if we needed. Okay, but that aside. So what putting this abstract keyword before shape does is it prevents me from instantiating objects of shape. If I go into my void main and I try to say shape, new shape equals shape, I can't do this. You see, it gives me an error. Abstract classes can't be instantiated. And this is exactly what I want, because as I was saying before, there's no such thing as an actual shape. We only have examples of shape. So you can imagine I will need to extend the shape to get a concrete interpretation. So what I could do is I could say class rectangle. And do you guys remember, should I use extends or should I use implements here? Well, I'm going to use implements. And so I have a weird bug where this is jumping around. The reason I'm using implements is because this get area function is just a prototype. It shows me what I want the function to look like, but it doesn't contain that function body. Whereas when I have the concrete implementation of each shape, for example, rectangle, I want rectangle to be forced to override it. I don't want to, say somebody's being lazy or just forgetful. I don't want somebody to be able to say rectangle, rectangle equals rectangle, and then without overriding it, say rectangle.getArea, because then it's just going to go to shapes get area and it doesn't do anything. So that's gonna break my code, and I don't want my code broken. So that is exactly why I am implementing rather than extending. And now, because I have the error, one of the reasons I love VS Code is I can just hit Control and dot, and let's make sure I have this selected, and it's going to give me this option to change my code. And the top one here creates one missing override. If I click this, it's going to, well, it's going to create the missing override. So now you can see I have function exactly in the same way as the shape function does, but now I can actually make it do something. So I could say, in fact, before this, I should put some variables in rectangle. So what makes a rectangle is a double width and a double height. And I would also expect rectangle to have a constructor. And I'll use named parameters because I just prefer named parameters. This.width, this.height. And then my getArea will return width.height. So there's that. This thing is really jumping around a lot. Microsoft needs to fix that bug. It's not the most pleasant. But that aside. So now rectangle is a concrete implementation of shape, the abstract class. And to really understand polymorphism, I need to extend this even further. I could then make a class square, which, do you know what, guys? I'm going to get rid of this because that thing jumping around is kind of annoying me. So I'm going to say class square, and this one I'm going to extend rectangle. And again, why am I doing this? Because a square is a rectangle. Unlike rectangle and shape, you know, shape, the rectangle needs to override everything that the shape has, but the square can use everything that the rectangle has. It can make things easier in a way. And what I'm going to do here is instead of having a double width and a double height, we all know that the square has the same width and height, that's what makes it a square, I'll say just double side. And then in its constructor, I'll say square, and I'm going to use a positional argument because unlike rectangle, I only have one argument. I don't want to confuse people or just waste time writing extra code. So I'll write this.side. And now, how about width and height? You might be looking at this and thinking to yourself, in fact, let's do this. What if I say at required and at required, and I do need to import something to use this required annotation. I'll use control dot again, and it doesn't give me any default import, which it really should. But okay, so I'll just import it by hand. I'll import, and I have a few choices. How about Flutter package, Flutter matter.dart. It's not accepting it. What if I just do impem? Oh, okay. So actually I can't do this because this isn't a Flutter project, it's just a Dart project. And if I'm not mistaken, required comes from Flutter, not from Dart. So I actually can't use this. What that would have done if it worked was this required annotation means that it's required. I can't make something without having whatever is annotated as required. So then square, which is a rectangle, having only side, would have an error because it doesn't have the width and the height yet. And I do say yet because this is easy to fix using our next keyword, which is super. What super does is super lets us access things in the parent class. and I'll just write it here. Super lets us access things in the parents class. Specifically, I'm going to access the rectangle constructor in this case. So what you have to do is after your constructor, you'll put a regular colon, not a semicolon, and then super. And then in your curly brace, I can say width side and height side. So what this is doing is when I make a new square and I'm forced to pass in the side, this side will then be passed in to the rectangles constructor as both the width and the height. So in so doing, a square is exactly what it should be, a rectangle with the same width and height. And let me just get rid of these because I can't use it, turns out. And because I've done this, I already have my rectangle, and I can also have a square, square equals square. And let's say my rectangle, I'll give it a width of 2, height of 4. And my square can have a side of 4. And I do need to print both of these because I'm returning a double, I'm not printing anything. Here. And then print square dot get area. This is all fine. So if I just run this, this is in v13. You can see both of them work. So in square, even though I didn't define the get area function, it's using its parent get area function. And in get area, in rectangle, although this has a width and a height, both of these were gotten from just a single variable side in square. Okay, so I'm just going to create a couple more classes for, and I need to get rid of this again. I don't know why it's jumping around like that. I shouldn't be doing that. So before we can jump to polymorphism, just a couple more classes. An oval implements a circle, implements a shape. And then oval would have a double minor radius and a final double major radius. And if I just control click, one missing override, get rid of this, and instead I can return, and if I'm not mistaken, it's minor radius, major radius times pi. And with pi, obviously I don't have an actual, I haven't defined pi, but I can import it from dart.math. C control clicking lets me import library dart.math. And I'm actually going to import it as math. What this does is rather than just giving me, just throwing everything at me, all the variables in dart.math, to use them, I actually need to specify like this. math.pi. So this lets me get this pi from here. If I don't have math.pi, I would just say .pi. But math has so many things that I don't want to do anything strange. And I did forget the constructor. So I'm just going to control click and create constructor for final fields. And this is positional. So instead I will make it named. I prefer named arguments. And that's fine. And then just one final one, class circle extends oval, and this is going to be the same as a square in that I'll take radius instead of minor and major radius, and in fact I'll just control click, create constructor, and then I just need to use that colon, and the super of course is going to give me the ovals constructor here, which takes minor radius, which I'll pass radius, and major radius, in which I'll pass radius. And that was Control-Shift-I to ask Dart or VS Code to format the code nicely for me. So if I save this, now I'll just add one more small thing over here, print getting ovals area, and in rectangle, getting rectangles area. And there we go. Jumping back here. Now I can have an oval, oval equals oval. Oh, let's have a major radius of 10 and a minor radius of 5, because why not? And finally, circle, circle equals circle. And this will have a radius of 7.5, because why not? Okay, now that we have all of this, we're finally ready to get to polymorphism. So now you can see that we have 4 different types. There's a rectangle, a square, an oval, and a circle. Of course, a circle is an oval, a square is a rectangle, and all of these are shapes. So a shape is the grandfather of square and circle, and the father of rectangle and oval. So what can we do here? Well, they all have a similar interface. They're constructed in different ways, but they all take everything from the shape class. So we can use whatever shape has for all of them at the same time to simplify our code. So one thing I could do, remember our list can take a type. I can make a list and pass in shape. And remember from before, when we tried to make a shape equals shape, it didn't let us do this. It didn't like this because it's an abstract class. It doesn't like that. But I can do it here. A list shape, and I'll say shapes list equals, and I can put in my square brackets some shapes. A rectangle, a square, an oval, and a circle, which I spelled wrong. So even though I can't have any instance of shape itself, I can use all of its children as this object. And this is polymorphism. Using a class's children as that object. And specifically, as I mentioned at the beginning, this is subtyping, because each of these, a rectangle, square, and so on, are subtypes of shape. We tend to use the word class here, but same thing as a type. And one more thing which is really, really interesting about this is, I'm sure you guys remember, I have for each on a loop, and I can take an element here. One thing I could do, and this should be shapes list. One thing I could do is I could take element.getArea. And this is another important aspect of polymorphism, because a language that is polymorphic knows to get the right data, and in this case we're accessing a function, but in other cases it might be a variable, whatever, from the right class. Obviously the getArea function on a rectangle and a circle are not the same. If a language was not polymorphic, if it wasn't OOP, then I wouldn't be able to just call getArea on both a rectangle and a circle at the same time. That wouldn't make any sense. But because it is polymorphic, I can run this, and we can see for my rectangle, I'm getting the rectangles area. The square is still accessing that rectangles area because we didn't override the getArea. The oval, of course, is getting its own area, and the circle is doing the same thing. So again, because Dart is OOP, because it's object-oriented programming, and because we have access to polymorphism, we can then use a single call to getArea for all the different shapes. And Dart by itself knows, hey, when I have getArea on a rectangle, I'll go get the rectangles function. And on the other hand, when I have getArea for an oval, I will go get the ovals function. And these are, at the end of the day, 2 different functions. They're not the same thing. But Dart can figure out which one we want from this. Okay, so maybe that was a lot, maybe super easy, I don't know. But you might be curious where you might want to use this. The main place that I personally have used it is in clean code. And you might be thinking to yourself, first of all, what is this? Second of all, why do I care about clean code? We'll get into that in a later date. But essentially what I've done is, one of the hallmarks of clean code is that I should be able to swap out different things if they're not in the core layer. For example, my database. What you choose as your database shouldn't have a strong effect on your entire code. I should be able to write my code and just have that database chosen at the end. If I want to use Hive, which is a popular NoSQL database for Flutter, or if I want to use SQLite or anything like that, the rest of my code should be the same. So one thing I can do is just have a database layer. I could call it, for example, a database class, an abstract class. And then from that, I can say something like class HiveDB implements database, or you could have a class SQLite DB implements database. And then in all the rest of your code, you never use HiveDB, you never use SQLite DB, you're always just going to use this DB. And because that way, it's very, very easy to switch between the two. You can use HiveDB for most of the time, and then when your boss comes in and says, hey, why are you using NoSQL? We need SQL. You can quickly switch it up and not have to go back and change every single last piece of your code. Because if you guys are beginners, most of the code you've made has probably been really, really small. But when you get to a larger project, currently I'm working on something where a single file is 500 lines of code. And that is one file in one layer, which is part of just a much bigger application. And overall, that application already has tens of thousands of lines of code. And I've only been working on it for a short while. It's nowhere near finished yet. So if I had to go back and change every single little piece because I changed my mind about which database to use, I would just go insane. But luckily, we have polymorphism, and I don't need to worry about that. So yeah, it's something which I personally am really, really thankful for. But if you guys are just beginning, you might not realize how amazing it is to have polymorphism yet. But yeah, that's that. Okay, so real quick review. Polymorphism is what allows us to use multiple different classes as its parent class. So I don't have to have a list of rectangles and circles. I can instead combine all of them into a list of shapes. And two more things we learned today. The abstract keyword says, hey, this is just like a blueprint. I don't want people to actually make this. It's just letting people know how they could make something from it. That was the abstract keyword. I could just write here, blueprints. And finally, we had super. Super basically says, take something from my parents or give something from my parents. And you'll very, very often see in the constructor some kind of class and then colon, super, and then using the parents constructor here instead. Okay, guys. So that was it from me today. I hope you guys learned a lot, and be sure to stick around till next time because we'll explore the final pillar of OOP, which is abstraction. It's going to be a shorter lesson than this one, but it's going to be amazing nonetheless. So that was it from me for today. Make sure you like the video, subscribe to the channel, and for myself, for now, Ovidius, I am out.